Now we can investigate the intrinsic spin of the decay products of the C quark. Initially, again, if we eliminate particle-antiparticle pairs, we will have the spin of the two anti-V rishons and the spin of the dual relating V rishon, which are -1/2, -1/2, and +1/2. So the spin on the initial C quark is -1/2. It's a left-handed spin particle. Now, you may note that the spin on the boson plus here is actually 0, as if it's a scalar. And when you have a composite system that includes a boson plus, then the boson plus will exhibit a 0 spin or expressed as a scalar. But when it's emitted, then it will be necessary for it to exhibit the appropriate spin for a W boson, which is plus or minus 1. So in this case, as a result of the Higgs mechanism, we can see that what will happen is something like a photon will be emitted by this rishon, changing its spin to -1, and will be absorbed by this anti-rishon, changing its spin to 1, and thereby giving the appropriate spin quantum for this W minus boson of +1/2, +1, and for this W plus of -1. Now, initially, we had a left-handed C quark, and we then had the emission of two weakly interacting massive particles, which both had a spin of 0. And the spin on the S quark, we can see, is 1/2. So we can see that the initial left-handed spin is recovered when we look at the anti-electron, which has a spin of 1/2, and the neutrino, which has a spin of -1/2, which these two actually cancel one another also, giving us a spin 0. But then we have a Z boson being emitted, which carries away the left-handed or -1 spin, -1 spin that combined with the S quark will give you your initial left-handed or -1/2 spin of the C quark. Now, and then we have a boson 0 here, which has a spin of 0, a scalar. Now, to see if there's any necessary corrections to these decay products, we must check the weak charge, or weak isospin. And we can see that the weak isospin on the W plus here is indicated correctly, which is a weak isospin of 1. The weak isospin on the D quark is Now minus 1/2, and the weak isospin on the anti-U quark is also minus 1/2. So we have minus 1 and plus 1 giving us a 0 altogether for the weak isospin here. Now, if we look at what we initially had with the C quark composed of the two V rishons and the dual relating V rishon, then we will see that we have 2/3 combined with a minus 1/3 gives us 1/3, and 1/3 plus 1/6 will give us 1/2. So the weak charge on the left-handed D quark initially, left-handed C quark initially was plus 1/2, which is indicated by the standard model. So the sum of the decay products should also be plus 1/2. So here on the D quark, which is now a right-handed spin D quark, we have a weak charge of plus 1/3 and minus 2/3, which is 0, which is correct for the right-handed particle. It has a 0 weak charge. And if we look at the weak charge on the anti-electron, we can see that it is plus 1/2 as indicated by the standard model. And on the neutrino, which is left-handed, we have also a weak charge of plus 1/2. Now, for each of these weakly interacting massive particles, the weak charge is 0. Now, the Z boson here, though, we can see has a weak charge of minus 1, which is incorrect according to the standard model. And so we will require a Higgs mechanism process, which will change the weak charge on this alternating rishon and its corresponding partner, anti-rishon, and in doing so, we then will have the Z boson will have a weak charge of 0, which is appropriate according to the standard model, but that is only due to an interaction with the Higgs field, which the Higgs quantity then is being indicated right here by this antiparticle and particle, which have a weak charge of minus 1, but have a spin of 0. So this is an actual Higgs excitation, an excitation of the Higgs field, which corrects the weak charge on the boson 0. The intrinsic spin, and isospin weak charge reversals that I have demonstrated here correspond in this composite model to the action of the Higgs mechanism in the standard model, and allow any emitted bosons from a composite system to have the appropriate weak charges and spin.